Right.
And, but Darth Vader, I mean, come on.
Yeah.
Luke, I am your father.
Do not overestimate the power of your technological terror.
Let me hear Luke, I am your father. Go.
No, Luke, I am your father.
Right.
Look search your feelings. You know it to be true.
Plus, CNN hasn't been the same ever since they stopped using his voice.
I'm
for that.
so like
they're using all the correspondence. It's like, don't you understand?
Exactly. I would love that gig.
I want the gig.
You want that gig?
No, I don't want you to have the gig.
We might have to fight about it now.
No, you'll lose.
Okay, you ready? Let's try it.
Here we go.
Ready?
Okay.
Let's audition. This is our audition for CNN. Ready?
Replacing James Earl. Do I want me to go first?
Yeah,
okay.
Absolutely.
This is CNN.
That's not bad.
So why do some voices, literal and cosmic, command belief even when a universe of data whispers otherwise? Start with this. The early universe could carry sound. Not metaphoric sound, but pressure waves sloshing through a hot plasma of photons and matter, ringing across space at roughly half the speed of light. That ocean of light and electrons left ripples we can still see today in the cosmic microwave background, faint temperature patterns that map where those waves crested and crashed before atoms first formed. The peaks in that pattern line up because the waves were coherent, like a choir hitting the same note. Those same ripples set a preferred separation between galaxies, about 150 million parsecs, etched into the large-scale structure as if the cosmos once kept time. The tension is this: chaotic beginnings, yet an afterimage of order so strong it still shapes where clusters form. When everything should be messy, why did one pattern carry farther than the rest? Part of the answer lies in the physics that made those waves possible. Before atoms existed, photons constantly bounced off free electrons, gluing radiation to matter. Gravity pulled, radiation pushed back, and the result was a ringing baryon photon fluid with a characteristic speed and a characteristic horizon, the farthest a wave could travel before the universe cooled enough to let light go free. When that cooling happened, the waves froze in place. A fossilized snapshot of motion turned into a map of temperature and density. You can read the map. The first acoustic peak tells you the curvature of space. The ratios between peaks weigh out how much normal matter exists versus dark matter. The subtle smearing of small-scale patterns reveals how tiny fluctuations were erased by diffusion, a process called silk damping. Meanwhile, dark matter, deaf to radiation pressure, fell into wells and stayed there, seeding the skeleton of cosmic structure that baryons later traced. The coherence is not an accident, it's dynamical memory. But if the early universe started with quantum jitters, why did those jitters line up across horizons that couldn't talk to each other? Inflation plays the role of a conductor here, setting phase across the orchestra. By stretching space exponentially, inflation took quantum fluctuations from subatomic scales and magnified them to cosmic size, imprinting nearly scale-invariant variations in density everywhere at once. That process made it possible for regions of the sky that were never in causal contact afterward to share the same initial conditions. So, when the plasma rang, it rang with synchronized phases. The acoustic peaks we observe require that synchronization. Random phases would smear out the peaks into a featureless wash. The spectrum is almost, but not exactly, scale-free. A slight tilt says the inflating field rolled in a potential that wasn't perfectly flat. The fluctuations themselves are nearly Gaussian, but their evolution wasn't uniform. Dark matter deepened wells while photons slipped away, leaving behind over and under densities that gravity later magnified. And, at small scales, the diffusion length blurred fine features, which is itself a measurement of how tightly coupled photons and electrons were before recombination. We're eavesdropping on the universe's first 400,000 years and hearing a consistent story. Yet, there's a deeper question lingering. Why do we, as minds, favor that kind of coherence whenever we find it? Because coherence compresses reality. A simple, lawful pattern explains more with less, and that's an economy of thought our brains evolved to exploit and our physics thrives on. Symmetries act like the lowest notes that carry through a hall. Translational and rotational symmetries tell you momentum and angular momentum are conserved, courtesy of Noether's theorem. Break those symmetries, and variety appears without losing the underlying simplicity. Spontaneous symmetry breaking lets a field like the Higgs pick a direction in an otherwise featureless landscape, giving particles mass while leaving the equations compact. Nature, at large scales, forgets microscopic details. Universality means boiling water, and magnets near critical points share exponents, even though their constituents are different. The renormalization group tells you why low-energy behavior depends only on a few relevant parameters. Black holes push this to an extreme. Regardless of what fell in, they are specified by little more than mass, spin, and charge. Complexity flows into attractors that erase the trivia. That's the same cognitive temptation behind a commanding voice, one signal that promises to stand in for many. But authority can be a mirage. Pareidolia sees constellations and noise. Parameter degeneracies let different cosmologies mimic one another. So how do we distinguish the voice that compresses truth from the voice that compresses us? We demand independent echoes. In physics, the most trusted signals are the ones that survive cross-examination by messengers that don't share the same weaknesses. We heard black holes merge not because one interferometer chirped, but because multiple detectors caught correlated vibrations with the right time delays and waveforms. We measured a cosmic expansion rate from a neutron-star collision. Its gravitational wave signal gave us distance, while the identified host galaxy provided a spectroscopic redshift, a standard siren, independent of the traditional distance ladder. After a very public misstep, mistaking galactic dust for primordial gravitational waves, we learned again that foregrounds can imitate the cosmos, so we build null tests and cross-correlate maps. CMB lensing with galaxy surveys, gamma-ray bursts with gravitational waves, neutrinos with blazar flares. Pulsar timing arrays now report a background hum in nanohertz gravitational waves, potentially from supermassive black hole binaries. Its spatial pattern across the sky is the fingerprint we need to separate it from clock noise. Even then, the universe imposes limits. Cosmic variance tells us there's only one sky, so uncertainties won't vanish with more observing time. Horizons hide information we cannot access. Anthropic selection means our sampling of reality is conditioned on our existence. Verification becomes an art of stitching together partial truths until a robust picture remains. Zoom back to the original tension, a single voice versus a universe of whispers. A voice earns authority in science not by its baritone, but by how many independent instruments it tunes with. The early universe's acoustic pattern doesn't just look pretty, it quantitatively locks onto curvature, matter content, and expansion history, and those lock onto supernovae distances, galaxy clustering, weak lensing shear, and the light of the oldest stars. Inflation is not a creed, it's a web of predictions, phase coherence, near-Gaussianity, a slight spectral tilt that a dozen measurements probe from different angles. Symmetries aren't slogans, they cash out as conserved quantities measured in colliders and telescopes. Even black holes' brutal simplicity is not a stylistic choice. It emerges from Einstein's equations and shows up as the ring-down frequencies we record when horizons settle. So, why do some voices, literal and cosmic, command belief even when a universe of data whispers otherwise? Because certain signals are amplified by the dynamics of reality into coherent patterns that compress vast complexity into a few testable claims, and when those claims survive independent checks, they stop being mere voices and become knowledge. Our brains are tuned to prefer such coherence because it reduces uncertainty. Our methods are built to punish imposters by forcing cross-consistency across messengers, scales, and epochs. The authority that matters isn't the voice we hear first, or the one that sounds most confident. It's the resonance that endures when photons, gravitational waves, neutrinos, and equations all agree. Like, if this was interesting, hit the subscribe for more.